This special school for boys uses the games they play in their spare time to support a rigorous maths curriculum. This is Balliol School in the north of England.
Fantastic start.
It's a residential school for boys with behavioural, emotional and social difficulties.
You need to think about angles, don't you, and pace.
Deputy Head and Maths teacher Peter Henderson.
My approach to math is to try and be as inclusive as possible. The children that arrive with us have all sorts of difficulties and have had problems in their life and in their experience of schooling prior to their arrival here. They each have a statement of special needs saying that their difficulties cause a barrier to their learning. And so I try to make the activities as much a part of their everyday life and fun as I possibly can. All these social activities can have a mathematical content to them. And so we were losing a trick if we didn't try and include the activities that they do in the evening and use that time to develop their experience.
So even when the boys are relaxing out of school hours, the residential staff feed some simple mathematical concepts into the games they play.
The first one is quite simple. It's how many darts it takes for you to hit the first 5 odd numbers. So Dan, what are the first 5 odd numbers?
1, 3 and 5.
First 5, so we need some more, we need 2 more.
7 and 9.
7 and 9, thank you, Jack. We're going to take it in turns. 3 darts.
We had a member of the residential learning team who works with the boys in the evening, actually taking them through some darts activities.
Cross off the 2 ones. And 1, fantastic, Dan.
We were talking about how we could challenge the boys to use language that they wouldn't normally use. They wouldn't normally use, give me the first 5 odd numbers, give me the first 5 even numbers, give me the next 3 multiples. But they could have fun while they did it.
Watch carefully, Dylan, now, because you could be caught out.
The idea behind the large 4 in a row was that the boys could physically manipulate the pieces and hopefully have a bit of fun while they were doing it. Try to develop some sort of strategy in order to win the game. So they started to think about how they place things and what order they place them. And then by putting just a simple set of axes on them, we could actually link that into the coordinates. And so we could connect the game into coordinates.
Well done, Dylan. You need to tell me the coordinates now.
Well, right, so that would be... That one's 4, 1, 5, 2, then 6, then 3, then 7, then 4.
And if the boys saw the activities as fun and could transfer it into the classroom, it's what I call putting mathematical currency in the bank. What were you asked to do on the dartboard? What sort of thing?
Hit the odd numbers.
Odd numbers?
Yeah, the first 5.
In the school's classroom, Peter follows up the maths in the games they were playing.
Dad, can you tell me what the first 5 even numbers were?
2, 4, 6, 8, 10.
And you had to throw darts and see how quickly you could get them?
Yeah.
Yeah. So on the sheet of paper I'm giving you now is a dartboard. Can I have a volunteer, please, to read the challenge?
How many different ways can you use up to 3 darts so that your score adds up to 20?
OK. In your mind, work out what you're trying to do. Could you score a 20 in 1 dart?
Yeah. Yeah.
Yeah? Could you score a 20 in 2 darts?
Yeah.
And could you score a 20 in 3 darts?
Yeah.
Yeah. So what else is on the dartboard that makes it a little bit more complicated than just saying 10 and 10?
The double ring, the triple ring, the bullseye, and the bull.
So could someone give me 20 in 2 darts?
15 and 5.
15 and 5. Could somebody give me a 20 in 3 darts using the double ring? Dylan?
10 and double 5.
10 and double 5. So how many darts have we used there?
3. 2. Oh.
2. So you understand the problem. I want you to write down how many different ways you can make the 20. Keep that thought in mind. Don't let it out yet, because I want you to put it on a bit of paper.
Pen, please, as well, sir.
In the school setting, I like to set the lads a challenge to share ideas and to work socially together. All sorts of benefits that could come out of that.
17, 2, 1.
17, 2 and 1, that's 20.
19 and 1. 1. 1 plus 9. 2 plus 8. What? Math wrong. 19. 2 plus 18. 3 plus 17. 6 plus 14.
10, 5 and 5. 10, 5 and 5.
Double 10, double 1 and double 4. Now how about using a double?
I can't do that.
Well, let's try this. What did we say before? That's the double, that's the triple, that's the double. So what did we say? Double. Try this one. If it's double
7 is 14.
Let's just jot that down, shall we? 14.
16 and 4, 15 and 5, 14 and 6 and going
You've got it in your head, keep them in your head because you can't write that fast.
Have you got 18 plus 1 plus 1? Put
If we did that, then we would go on forever, wouldn't we?
Put it down, because then we have more and more.
Double 3 is 6, then double 4 is 8, so that is 14. Then double 3 is 6, that makes 20.
I'm going to give you a challenge. And Brian, you read the last one so well. Do you mind reading the next one?
With a partner, play the 4 in a row game and record the coordinates of the winning line. How many different types of winning line can you find? What do you notice about the coordinates?
Brian, how do you work out the coordinates for something?
I do along the corridor and up the stairs.
Along the corridor and up the stairs. What do you mean by going along the corridor? Can you put that in some other
Go
words?
across the x-axis.
Across the x-axis. Brilliant. So what's up the stairs then?
The y-axis.
So you're challenged, Jordan.
You have to find out how many different ways you can win 4 in a row.
So you don't necessarily have to play the game. You've got to look to connect 4 in a row and write down what the coordinates of those 4 are. And there's going to be lots of different ways of doing it. And you're going to try and find as many different ways as you can. And then look at the coordinates and see if you can come up with any kind of patterns to work out, if somebody gave you just the coordinates, what sort of connection that would be. Look at these coordinates.
Try and make a 4 in a row. 4 in a row.
Damn it!
4 in a row.
Oh, this is unbelievable.
And what sort of shape, how would you describe that series of 4?
Diagonal.
What word?
Diagonal.
Diagonal, yeah. See if you can write that down there in your writing. So that reminds you, if they're the same, it's the diagonal.
He's made one.
It's best if you both look at it from the same side so you can see this. You've got one?
Yeah.
What do you notice?
They're all in one.
They're all 1. So that, what do you call that number there in the coordinates? Is it the x coordinate or the y coordinate?
X.
Look again.
Which one? What? The what?
Is it the x or the y?
Oh, that's the y.
That's the y. So the y coordinate there is the same.
Climb.
So that gives you a line going that way.
Right? Oh, that was actually a bit of a...
Okay.
I win.
Oh, beat me 5 times.
The nature of the children is that prior to their arrival here, they've failed. They feel failed. Their self-esteem is low because they're not at home and they're not in their normal school setting, their mainstream school setting. They've come away to a special school to help them overcome any difficulties they have. That means that they find it very difficult forming relationships and working together with other people. So part of the working in pairs and working as a group, albeit a small group, and that is the beauty of a school like this, is that the maximum class size is going to be 8, possibly 9. Then you can work the dynamics together so that they overcome their difficulties and they develop socially and emotionally and behaviourally. Dylan, I love the way that you've represented your answers because you've come up with the answer to the challenge, or answers to the challenge, and you've decided to show it in a particular way. Can you tell me what you've done?
We've written the coordinates, but also shown the circle, the little pieces, which way they went to get the coordinates.
And how many different ways did you find?
4.
4 different ways. And did you notice any patterns?
Yeah.
Give me an example.
When it went horizontal, then they were all 1s, the y-axis.
The y coordinates.
When it went diagonal going right, they were both the same numbers, like 1, 2, 3, 4, 1, 2, 3, 4.
So the x and y coordinates were the same?
Yeah.
Yeah. What else?
And then when it was going up, the x ones are all 3.
Yeah.
When it's going diagonal left,
goes down.
It was going 4, 3, 2, 1, and then on the X it was 4, 3, 2, 1, and the Y it was 1, 2, 3, 4.
So they were the same numbers but reversed?
Yeah.
Brilliant, well done. That's fantastic.
The boys then go on to use a computer game to explore coordinates in all 4 quadrants.
You've got to get Billy Bug to all of his food, and it tells you where to go, because it has a little coordinate up there. Oh, I'm not doing very good. Done! 44 seconds.
Say that again.
44 seconds.
44 seconds, that's excellent.
Minus 4-2. I think it's there.
I know it's working because the lads tell me they enjoy it. For example, in the connecting coordinates, the objective was to be able to plot coordinates in all 4 quadrants. And by making it fun and playing the game, the Billy Bug game, they were managing to plot coordinates in all 4 quadrants, and they were also doing it in under a minute. So plotting 10 coordinates in all 4 quadrants in under a minute, I could see that the boys were doing it.
And Peter has more evidence to support his work.
I then put the key process skills as a map, and when I take my assessment at the end and after the activity and I consider it, I highlight in yellow which of the key process skills I felt were achieved. For example, in analysing there's reasoning, and in the reasoning there was justifying, working logically, making connections. You could see all that today in the activity that we followed. Then I linked that to the personal learning and thinking skills, working as part of a team. Were they self-managers? Were they effective participants? I've coded those. So I1, for example, is for independent inquirers, identify questions to answer and problems to resolve. Level 4, 5 is where I pitched it. I then have a comment at the end saying how the boys enjoyed it or if there's anything for further development.
It's just to make it more fun as a math lesson, so instead of getting bored. Like at a mainstream school you couldn't do that because there's 30 kids and you start messing around and stuff.
So is having the boys living in the school in some ways an advantage?
I think we do have an advantage because we have the children for longer, and particularly in the situation where we encourage staff to form positive working relationships with the children. And I've tried to use all sorts of styles of learning. There's the physical learning where they're actually physically moving. There's the one where they're solving the challenges and they have to think and write down the answers, so they're reading and writing. There's the one where it's the visual side of it where I use the computers to get that visual stimulus as well. So there's auditory, visual, kinesthetic, all those sort of learning styles I try to embody in the activities.
Should be a different game.
Yeah, we should play them again.
If I said to the lads, why do you do maths? Why is maths important? The normal answer is you need it for a job. But equally, you can need maths for playing a game of darts down the pub when you're older. So their social development, maths is crucial to helping them take an active and important part in their life and in society in general.